Hello student, today we are going to discuss the optics algorithms. In optics algorithm, uh, in optic algorithm is a density based clustering technique. It is there are this density based clustering technique is very much similar to the DWDM algorithm, but it is actually an reformation or advanced form of the DB scan algorithm. There is a slight difference in between the DB scan algorithm and optics algorithm. Before understanding optics, we must know the basics of the DB scan algorithm. The DB scan algorithm, that is basically a density based clustering technique. In density based clustering technique, the area which are denser are considered as the cluster, and the two clusters are separated with each other by a low density region. So in density cluster region, we try to find out the region which are relatively dense in comparison to its neighbor. So this is also a density based clustering technique and advanced form of the DB scan algorithm. As I have told you, that density-based clustering locates region of high density that are separated from another by the region of low density. The density is measured by the number of points within the specified radius. We count that within the specified number how many points are there, and the the higher the number, the denser the region. The rarer the region, the least the number of the position elements, the rarer the region. So this is very much. So first of all, we shall discuss what is DB scan algorithm. In the DB scan algorithm, there are two parameters: the epsilon and the min points. Epsilon is basically the maximum radius of the neighborhood, and the min point is the minimum number of points required in the neighborhood of a core object. So when we select a point, we draw a circle with radius epsilon, and in the epsilon, if the number of the nodes is more than the defined min point, minimum number of points, then it is considered as a dense region, otherwise rare. Here in DB scan algorithm, we start with these two parameters, the epsilon distance and the min points. But there nothing has been told about the how we shall select these two. So this is very a little encumbersome. It encumbers user with the responsibility of selecting the parameter value that will lead to the discovery of acceptable cluster. Suppose somebody select with different value of epsilon and endpoints, then he would cluster in a very different form. If the value of epsilon is relatively high, then we can combine or we can form a cluster of a size that does not actually represents the cluster. And if we select similarly the very few number of min point criteria, then it could also happen. So the selection of these two parameters was not very well defined in the DB scan algorithm. And this was the main reason that in optics algorithm, we derived a new terminology and solution for this up to some extent to work it more efficiently. So how these two criteria work in DB scan, later on we shall discuss that how it has been modified in the optics algorithm. And density-based clusters are monotonic with respect to the neighborhood threshold. In DB scan algorithm, for a fixed min point value and two neighborhood thresholds, epsilon 1 is less than epsilon 2, a cluster C with respect to epsilon 1 and min points must be a subset of cluster C with respect to epsilon 2 and minimum 2. Definitely, it is very clear. Suppose we are drawing the two circle, one with the distance epsilon 1 and one with the distance radius epsilon 2. And suppose epsilon 1 is a smaller radius, circle with a smaller radius in comparison to the circle with radius epsilon 2. Then in this case, the number of points that would lie inside the epsilon 1 radius would be definitely be less than the epsilon 2 radius, because it would be a subset of it, and the number of points would definitely be really less than the number of points lying inside the epsilon 2 radius. So min point, it's very obvious fact that the min point must be a subset of the cluster C with respect to epsilon 2 radius and min points. This means that if two objects are in the density based cluster, they must also be in a cluster with lower density required. So if it is clearly means if we are set, if a cell points are satisfying the higher density criteria, then they shall definitely satisfy the lower density criteria. So this is very obvious point, and but to overcome the difficulty in using one set of global parameter in clustering analysis, a cluster analysis called optics was proposed. But that I have already told you that the optics is the method in which this uncertainty of epsilon and min points has been properly resolved up to some extent. And the another points here that the C1 and C2 are the density based cluster with respect to E2, where epsilon E2 is means epsilon 2 and epsilon 2 is less than epsilon 1. And C is the density based cluster with respect to E1, completely containing the set C1 and C2. C is the C is the density based cluster which is used to combine both C1 and C2 and contains both of these two. Then for a constant min points value, density based cluster with respect to higher density are completely contained in density connected set with respect to lower connectivity. As I've told you, in the case of if epsilon 1 is greater than epsilon 2, then definitely the density criteria that has been satisfied by the epsilon 1 radius would also be satisfied by the epsilon 2 radius. Uh, for uh, for the radius that for the same min point value, then obviously that would be the better representation. So we try to find out basically the optimal value of the epsilon radius that would contain the minimum number of points. And for this I want to show you the term that is used in the slide here. Here in the diagram, a new term has been defined in optic clustering techniques, the core distance. As in the given diagram, we can see that there is a point P and the minimum point criteria is equals to 5. And the epsilon distance that has been assumed was 6 millimeter. And the radius of 6 millimeter has been drawn. And we find out that there are total 9 number of points inside the circle with radius 6 millimeter. That is greater than min point criteria. But we want to find out the optimal radius circle which have the which satisfies the min point criteria. Then we find out that the circle with the radius 3 millimeter can satisfy the criteria of min points, and it is the minimum possible radius circle that satisfies the criteria. So the minimum distance circle that cover the min point criteria is called the core distance, and it is the minimum value of radius required to classify a given point as a core point. If the given point is not a core point, then its core distance is undefined. Suppose if point does not have minimum number of point inside the epsilon radius circle, then it would not have any core distance. Only the point that have minimum number of points or more than minimum number of points inside the epsilon radius circle could have the core distance. The core distance, the minimum, is basically the minimum distance radius which satisfy the min point criteria. That is the point used in the optics clustering. It is the reformation of the previously defined epsilon radius. Now it has been replaced by the core distance. The next point, I'm taking you back to the previous slide. Um, Here the criteria. So here the same thing has been explained, that The optic work in the principle like such an extended DB scan algorithm for an infinite number of distance parameter epsilon 1, which are smaller than a generating distance, and epsilon 1 is less than the initial epsilon value. The only difference thing is that we do not assign cluster membership. Instead, we store the order in which the objects are processed, and the information would be used by the extended DB scan algorithm to assign cluster membership. So basically they are defining the core distance that I have explained you in the second slide. The same thing has been written here. Optics does not explicitly produce a dataset clustering. It outputs a cluster ordering. It is linear list of object under analysis and represents the density-based clustering structure of the data. The object in a denser clusters are listed closer to each other in the cluster ordering. Ordering is equivalent to density-based clustering obtained from the wide range of parameter setting. Thus, optics does not require the use of provide specific density threshold, because here the denser cluster are listed closer to each other, and the reason that are not close enough are listed in a more separated form. The cluster ordering can be used to extract basic clustering information. The cluster center arbitrary shaped cluster also. The two terms that are used, another term that is used in the optics is the reachability distance that we have also studied while studying the DB scan algorithm. In DB scan algorithm, the terminology that we have used epsilon neighborhood. Epsilon neighborhood are the neighbor that lies inside the epsilon radius circle. The next thing, the core object. All the points which have the at least minimum number of points or more than minimum number of points inside the epsilon radius are called as the core object. In the given diagram, uh, the midpoint criteria is 4, and P, when we draw a circle around P with epsilon radius, then we find out that there are 4 points inside the circle, so it is a core point. While on the other hand, Q is just having 3 points inside the circle, so it is not the core point. So P is the core point, but Q is not a core point. And the second term that is used, the directly density reachable. An object Q is directly density reachable from P if Q is within the epsilon neighborhood of P and Q is a core object. So simply, we can define it as the point that lies in the epsilon radius of any core points are called said to be directly density reachable to that core point. Here in the same diagram, the P that is a core point and Q is not a core point. So here Q is close to a core point, so Q is directly density reachable to P. And since Q is not a Q is not a core point, and but P is accessible from within epsilon radius, so P is not directly density reachable from Q. So this is an asymmetric relation. So simply, a point that is in the epsilon radius of a core point is called the directly density reachable. The next term is used as density reachable. An object P is density reachable from Q with respect to epsilon and min point if there is a chain of object P1, P2 up to Pn, such that if P1 is equals to Q, then there is a chain goes up to Pn equals to P, such that Pi plus 1 is directly density reachable from Pi with respect to epsilon and min points for all I lying between 1 to n. Here we can say that if through a series of core points, a point is accessible to a remote core point, then that point is said to be the density reachable from that core point. So with a series of core points that are density reachable to each other, a point that are connected to this chain are called the density reachable to each of the points. Here the P point is a core point. The point that lies on the intersection of these P and Q is also a core point, as it satisfies the criteria of more than 4 number of points. But Q is not satisfying the core point. But through its directly density reachable to a core point, and that core point is directly density reachable to P. So Q is directly density reachable to point P. So it is a transitive closure of directly density reachable, and it is also a symmetric relation because P is not directly density reachable to Q. The second terminology for that I am going to explain you through the next another slide. The term used is the reachability distance. This is the new modification of the DB scan algorithm. The reachability distance, it is defined with respect to another data point Q. The reachability distance between a point P and Q is the maximum of the core distance of P and the Euclidean distance between point P and Q. Note that the reachability distance is not defined in Q is not a core point. If it is not a core point, suppose it's the same figure that we use, that the epsilon radius initially is 6 millimeter and min point criteria is equals to 5, and the core distance, the min point, the core distance, like the in previous example we have seen, that is 3 millimeter, because while drawing the 3 millimeter circle we can find out the minimum number point inside the circle. So core distance is equal to 3 millimeter. Now suppose there is a point Q and Q is a core point. Then the and P is a core point, Q is a core point. Both are core points. Then their distance in between is equal to 7 millimeter. Then the reachability distance between point PQ would be the maximum of the distance between the two core points and the core distance of the point P. So the core distance of point P is equal to 3 millimeter, and the distance between P and Q is equals to 7 millimeters. So the maximum of 3 and 7 is equal to 7 millimeters. So reachability distance between point Q and P would be equals to 7 millimeter. Similarly, for a point R that is at a distance of 3, uh, that is uh, the distance between P and R is less than 3 millimeter, and the core distance is equal to 3 millimeter. So the maximum distance between 3 millimeter and less than 3 millimeter is 3 millimeter. So reachability distance between point R and P is equals to 3 millimeter. So this is called the reachability distance. Reachability distance is basically the distance between the two core points, maximum of the core points, and the core distance, it's a maximum in between these two. The same thing is, I'm taking you to the previous slide. Uh, the same thing is represented here. Here, the reachability distance between point P and O is equals to max of core distance and to the core distance and the distance between min points and distance between PO. Similarly, the formula may look a little bit complicated, but here there are 2 points, O point, P point. And we want to find out the maximum, the reachability distance. So distance between epsilon and min points, that's the distance, core distance, and the distance PO distance, and distance of whichever maximum in these between two is called as the reachability distance. So we know the two-term reachability distance and the core distance that will be used in optic computation. And now we go for an example. Before going to example, it uses the objects in order seed, which are sorted by the reachability distance from their respective closest core object. That's by the smallest reachability distance of each object. These are the steps. It computes the ordering of all the object in a game database. It stores the core distance and the suitable reachability distance of each object in the database. Optics maintain a list called ordered seed to generate the output ordering. I know that you will not be very clear about these, what I'm saying to you. So I'm taking you to the example. So in the given diagram, there are 16 points from A to N. These points are randomly scattered. Here the min point criteria is equals to 3 and epsilon is equals to 44. So the seed list will be prepared. We start from A, and from A that we find out that the distance of A from B is equals to 40, and up with I is equals to distance is equals to 40. So the core distance is equals to B40 I40, and in this way we mark that now we take the A process, we get the point B, and after B we process, they find out that their next accessible elements are C, C40, C at a distance, C is the criteria, C40, and then after that similarly we maintain the list, then A, I40 through I taken as the core point, I through I, we draw the circle through I, we got the point J20, K20 at a distance of 20, and with increasing density distribution condition, we draw the, we put them in the list, in the seed list. So the first, this list will be processed on the basis of minimum reachability distance, and in this way, after processing, when we cover all the elements in the list, similarly the list will proceed like this, and the distance will be marked by the bar length, and in this way we get a complete bar, and in this bar we find out that the point, if a cluster is completely processed, then we color it in a different way, and after that we move, start with a new color in the we have started with a new color in the diagram. And in this way, when the list get complete, we see that the, while the height of the bar when represented graphically, this looks like that. The three curves represents that there are three types of clusters. It helps to visualize and understand the clustering structure in the database. And the dataset cluster ordering can be represented graphically. So the length of the bar easily represents the graphs, the visualize, create the visualize the that there are three cluster because there are three curved region. So in this way, the algorithm is the reformation of the DB scan algorithm. Uh, it simply turned out that the runtime of optics was almost constantly 1.6 times the runtime of the DB scan algorithm. Not surprising that since the runtime of optics as well as for DB scan is heavily dominated by the runtime of the epsilon neighborhood query, which must be performed for each object in the database. So the runtime for both the algorithm is O, the O of maximum of the N into runtime of the epsilon neighborhood query. And okay, but in some cases it can be reach up to the ON square when the without any index support, such a region query can need to scan the whole the database, so it reach up to the ON square also. And with a better tree based indexing, we can reduce it to the O and log n level. So this is the performance. And for finally, optics compute augmented cluster ordering of the database. The main advantage of the approach when compared to the clustering algorithms, it do not limit to one global parameter setting. We do not need to initially fix epsilon value that was fixed in the DB scan algorithm without the basic knowledge, and it was very uncertain. So without caring much about the epsilon distance and the min point criteria, it can work very efficiently and better than the DB scan algorithm.